Okay, so we want to talk a little bit about polynomial inequalities. This is section 3.4, polynomial and rational inequalities. Okay, and this is based on the same ideas we used before. So I'm solving things like our first example, x cubed minus 2x squared minus 3x is greater than 0. Okay, where I'll have a polynomial or rational function on this left side, and usually in all of these problems I'll encourage you to get 0 on the right side, okay, to see where this thing is positive or negative. Now once I have 0, right, the thing that will split this graph into parts that are negative, have negative outputs, and parts that have positive outputs are these zeros of the function, finding the x-intercepts. Find x-intercepts, or also points of discontinuity for rational functions. So we have these places in order to, and I just want you to think about this again, in order to move from this negative sphere up here to this positive sphere, I either have to pass through this point, or I possibly have to get either a vertical asymptote or hole where I'm like going to switch kind of which side this graph is on, right? So there's an example of a rational function where it's going to switch sign at this point of discontinuity. And we've seen that behavior in some of the ones that we've done. So I really want to find these places where it can switch signs that will kind of, again, be these barriers or for where the function is all negative or all positive are these x-intercepts and also points of discontinuity, okay? So here in this polynomial, I think this one might be factorable. Let's at least try and factor it all out. But I'm really thinking of f of x to be this x cubed minus 2x squared minus 3x. And I want to find the zeros, right? Because those are my points that split this function. So I'll try and factor this. X minus 3 and x plus 1 I think works. So I get 3 zeros, and again we'll use this interval testing, just like we did with quadratics. And otherwise, besides the fact that we have kind of more points to consider, it's exactly the same, okay? So here my zeros are x is equal to 3, or 0, x is equal to 3, and x is equal to minus 1. I still kind of have this number line that I write, negative 1, there's 0, there's 3 out there. And in my head, it splits this in the real domain of the function into intervals, right? So, but I have all these intervals, minus infinity to minus 1, minus 1 to 0, 0 to 3, and 3 to infinity. I have all those 4 intervals that I have to test points in. I want to pick a test point, if you remember, from each of these intervals. So let's pick negative 2, let's pick negative 0.5 there, pick 2, and let's pick 4. Okay, and then I plug them into that function f that I defined as the left side of that inequality. So let me put that in. So I want to plug in x cubed minus 2x squared, x cubed 2x squared minus 3x. Okay, and I got negative 10.875, negative 6, and 20. Is that what you guys got? Okay. So then I go back, and the original inequality was finding where f of x, I believe, was positive. Okay. That's right here and right here in those two intervals. So f of x is positive on minus 1 to 0. F of x positive on minus 1 to 0. And also on this last interval, which is 3 to infinity. Oh, I erased what I wanted. Hold on, I think I can bring that back. Or just write it again. Sometimes when I box things, it thinks I want to delete them. Yeah, I'll just double underline. Okay? Okay, so let's do another example. And if you kind of get the gist, maybe you can pause this and try it on your own, and then come back and compare with mine. So I want to find this 3x cubed plus 4x squared minus 7x plus 2 is less than 0. Okay, so I'll go ahead and solve it. It does not look like it's factorable to me by grouping, but so I'll make my list of rational zeros. Because I wanted to find, before I do that, I want to make sure that I'm clear about this. I have 0 on one side, so I wanted to find my f of x as the left-hand side of this. And then I want to find these places where it's 0, because those are the places that split the domain into places that are positive and negative. So in order to solve that, I have to go back to my rational zeros list, right? A0 is 2. That gives me my list for P, plus or minus 1 and 2. AN is 3. That's my list for Q. So P over Q, my final list is plus or minus 1, plus or minus 2, plus or minus 1/3, and plus or minus 2/3. Okay, I'm going to just test those in my calculator. 3x cubed and I got a winner at 0 of positive 2/3. Okay, let's confirm that with synthetic division, because I want to go ahead and whittle this down. So I have 2/3 here, and then I 3, 4, minus 7, and 2 from this function right here. Those are the coefficients, right? And then I want to go here, 3 times 2/3 is 2, that's 6. 6 times 2/3 should be 4, that's minus 3, minus 2, and 0, okay? So it turns out my function f of x, which is equal to this 3x cubed plus 4x squared minus 7x plus 2 is also equal to this x minus 2/3 times this quotient, 3x squared plus 6x minus 3. Okay? Okay, so then we want to possibly go ahead and just look at this right here. I don't think that is factorable either, but I can go ahead and use the quadratic formula to find the zeros. Okay, so x is equal to negative b square root b squared minus 4ac all over 2a. Negative 6 plus or minus the square root of 36 minus 4 times 3, and c is negative 3, so be careful with those signs, and 2 times 3 there. And let me plug this into my calculator. And I got 72 in here, all over 6. And 72 has 36 inside of it. So I get x is equal to, right, 6 square roots of 2 divided by 6. And that will give me negative 1 plus or minus the square root of 2. Okay, decimal approximations to put on my number line, because please don't forget where we're going. We're still trying to do this interval testing. I'm just finding zeros. So negative 1 plus the square root of 2 is 0.41. Negative 1 minus the square root of 2 is negative 2.41. So, and I still have that 2/3. So my when I go to do this test, my number line looks something like 2/3, right, is somewhere in here. So let's say I'm going to put 0 there. Negative 2.41 is right there, and that's the same thing as negative 1 minus the square root of 2. Right in here, 0.41 is negative 1 plus the square root of 2, and then I also have slightly over here 2/3, right, which is, or 0.67, or 6 repeating. Okay, so this is where my splits happen, not at 0. 0 isn't one of them. I kind of put that in as like just a reminder, because sometimes when these numbers get weird, it's a little bit harder to order them for some reason. I don't know why that is. Negative 2.41 to 0.41. 0.41 to 2/3, and 2/3 to infinity. But I'm still picking test points in here, right? So maybe negative 3 and negative 2 is in here, or also 0 is in here. That's usually a really easy point to test. So I'm going to pick that, 0.5, and then out here, let's pick 1. Okay? Let me make sure I've plugged this in, 4x squared. Okay, yes. So, and I'll go up. And I get, when I plug into that function, f of my test point, I get negative 22, 2 here, negative 0.125, and 2. Okay? So, and again, my original problem was where this f of x, 3x cubed plus 4x squared minus 7x plus 2 was less than 0. That's going to happen right here. Negative and negative is on minus infinity to negative 2.41, union 0.41 to 2/3. And you can also list these as the actual irrational numbers, radicals. Now, one final example I just want to say something about is this example, and then we'll do another video about rational functions or rational inequalities. So I have something like this. It turns out, and I'll let you guys go through this process, it turns out the zeros are plus or minus 5i, negative 3, and 1 for this function are the zeros for f of x is this left-hand side, x to the fourth plus 2x cubed. Okay, so I only have two real zeros, so when I set up my interval line, I really only have the numbers -3 and 1 as splitting this. I can't put plus or minus 5i on this number line, and they don't cause any sort of split. So I really just have 3 intervals that I have to test and see where those things are to solve this sort of problem. Okay, so don't let those complex solutions fool you or confuse you. They don't show up in the real plane. They don't show up on our real graph, so they don't really help to split the graph into positive and negative pieces as far as outputs go. Okay, let me know if you have questions.